All right, this is section 5.3, and we are going to be looking at evaluating trig functions, and we're going to be looking at them specifically with triangles in this section. So if we have a right triangle that has 90 degrees here, and if this is angle C, angle A, and angle B, so the respective opposite sides are labeled the same but lowercase, little a, little b, little c, then sine of some angle x, if this is some angle x here, sine of that angle would be the opposite over hypotenuse. So in this case, that would be A over C. And then cosine would be the adjacent over hypotenuse, so B over C. Tangent is opposite over adjacent, so A over B. And then the reciprocal functions are the reciprocal of each of those. So in this section, we're going to be evaluating angles in a triangle for all 6 trig functions. So let's look at the first example here. It says, find the value of each trig function for angle A. Let little a be 1 and little c be 3. So we don't know B. And the first thing we can do here is use the Pythagorean theorem to find it. So recall that the Pythagorean theorem is for right triangles. If I have a squared plus b squared, that's equal to c squared. And that's with c being the hypotenuse and a and b being legs of a right triangle. So I know that c is 3, so 3 squared would be 9. I don't know b, and I know that a is 1, so 1 squared is still 1. I can go ahead and subtract 1 from both sides, and then b squared is equal to 8. So b is equal to the square root of 8, which is 2 square root 2. And so 2 square root 2 is our b value here. If you're not sure how I got that 2 root 2, the square root of 8 is 2 times 2 times 2. When you have a square root, you need 2 of something to be able to pull 1 out. And so 2 square root 2. All right, so if we are looking at angle A, and that is angle A up here, then we want to evaluate sine, which is opposite over hypotenuse. So that would be 1/3. Now we're not talking about the coordinate plane here. We're not looking around the unit circle, so we're not worried about which trig function is positive or negative here. We're just referring to this triangle. So in this case, sine would be 1/3. Cosecant then would be the reciprocal of that, and the reciprocal of 1/3 is 3. Cosine is from angle A, the opposite over hypotenuse, so that would be 2 square root 2 over 3. And then this would be the reciprocal of that. Well, if I have 2 root, actually, let's flip it here. I have the reciprocal of that, 3 over 2 square root 2. I can rationalize by multiplying by square root 2 over square root 2. That becomes 3 root 2 over square root 2 times square root 2 is 2. 2 times 2 is 4. So 3 square root 2 over 4. And then tangent, remember, is the opposite side over the adjacent side. So 1/2 square root 2. Again, we can rationalize that. And then that would become square root 2 over square root of 2 times square root of 2 is 2. 2 times 2 is 4. So square root of 2 over 4. And then cotangent is the adjacent over the opposite. So square root of 2, 2 root 2 over 1 is just 2 square root 2. So that's how we would do something like that. Below here, we have what are called the cofunction identities. And we saw this kind of play out in our notes where we were looking at those special right triangles, the 30, 60, 90, and the 45, 45, 90 triangles. If you recall this page a few sections ago. And we saw that cosine of 30 degrees was equal to sine of 60. And we saw that sine of 30 was equal to cosine of 60. And we saw these relationships happening throughout these problems. Well, that's because these functions are cofunctions of one another. If I have sine of 30, that's going to be equal to cosine of 90 minus 30 would be 60, which is exactly what we saw happening with those special right triangles. This is true for any angle less than 90 degrees. So sine x being equal to cosine of 90 minus x. If x was 20 degrees, then 90 minus 20 would be 70. Sine of 20 is going to be equal to cosine of 70. And the same is true for the rest of these. So if we wanted these in radians, we would just replace 90 degrees with pi over 2. So these next couple examples ask us to find the cofunction with the same value. So sine's cofunction is cosine, and we would have 90 minus 46, and that would give us cosine of 44. So cosine of 44 degrees is equal to sine of 46. And cotangent of pi over 12, well, cotangent's cofunction is tangent. So tangent of, and we'll use radians now since this is in radians, so pi over 2 instead of 90, minus pi over 12. And then we have tangent of, this is 6 pi over 12, if I multiply by 6 over 6 here, minus pi over 12 gives me tangent of 5 pi over 12. Okay, so those two would be equivalent. Right, and on to the next page. If we are looking at any circle now, not just the unit circle, but a circle of any radius r, maybe a radius of 2 or 5, then we can generalize what all of these are equal to. So sine is going to be equal to y over r, cosine is x over r, tangent is y over x, and then the reciprocal functions are those reciprocals. So we can also just recall real quickly that in our coordinate plane here, this is quadrant 1, quadrant 2, 3, and 4. And then all of the trig functions are positive here. Sine and its reciprocal, so sine of x and cosecant of x are positive here. The rest of them are negative. Tangent and cotangent are positive in quadrant 3, and the rest of them are negative. And then cosine and secant are positive in quadrant 4. And then here it's all of them. All 6 are positive. So let's do another example. It says find or let P equal 1, negative 3 be a point on the terminal side of theta. Find each of the trig functions of theta. So here we have our point 1, negative 3. So let's go ahead and just plot that point really quickly. And 1, negative 3 right here in quadrant 4. And we want to draw our reference angle here. And so we're going to be using that triangle there. Let me go ahead and draw a larger version of this triangle for us to work with. So same triangle. And this distance here was 1. We went over 1 on the x-axis, and we went down 3 on the y-axis. So this is 3. And I can use the Pythagorean theorem to find that hypotenuse. So just real quickly, 1 squared plus 3 squared is 1 plus 9, and that's 10. So the square root of 10 is our hypotenuse. And it's asking us to find each of the trig functions of theta. Now, before I ever start evaluating anything, this is in quadrant 4. And cosine and secant are positive there, and the rest of them are negative. So before I ever even begin evaluating this triangle, I'm going to put a negative sign on each of those answers so that I don't forget to do that. Now, once I've drawn this triangle, it's just like the problem we just did, where we can just use the triangle to evaluate it, and we've already taken care of what's positive and negative. So we're looking at from this angle here, from the origin there, and we want to find sine of theta. So sine is opposite over hypotenuse. So that would be 3 over square root of 10, and we can rationalize that. And that gives me 3 root 10 over 10, and we already have the negative on there. Well, if sine was 3 over square root of 10, then cosecant is the reciprocal of that, square root of 10 over 3. And I don't need to rationalize that because there's no square root in the bottom. Cosine, if this is my angle here, is adjacent over hypotenuse, so 1 over the square root of 10. And again, I can rationalize that. And I get square root of 10 over 10. And this is positive in quadrant 4. So I don't need that negative on there. And then secant is the reciprocal of cosine. So that would be square root of 10 over 1, which is just the square root of 10. Now tangent is opposite over adjacent, so 3 over 1. And we already have the negative on there, so that'll be negative 3. And then cotangent is the reciprocal of tangent or adjacent over hypotenuse, and that would be 1/3, and it already has the negative on there. So when we're doing these kind of problems, it's really helpful from the very beginning to label which ones are going to be negative, which ones are positive. And then we can use our reference angle and create a triangle there and then evaluate from the triangle. These bottom two questions here say find the following, and we have secant of pi over 6. We can use the fact that it has a reciprocal function cosine of pi over 6. And cosine of pi over 6 is square root 3 over 2. So that becomes 1 times 2 over square root 3. And we can go ahead and rationalize. And that becomes 2 square root 3 over 3. Okay. All right. The next one, we have tangent of 17 pi over 4, and I already know that that is bigger than 2 pi, so I'm going to use those periodic properties and subtract 2 pi. So this is equal to tangent of 17 pi over 4 minus 2 pi, or 8 pi over 4. And then that would give me tangent of 9 pi over 4, which is still too big. So I can subtract 8 pi over 4 again. And then I have tangent of pi over 4. And this is the angle in quadrant 1 where sine and cosine are equal to each other. So sine of pi over 4 over cosine of pi over 4. Well, those are equal to one another. Those are both root 2 over 2. And so this is going to be equal to 1. Let's do one more example of plotting a point here. I have the point 2 or negative 2, 1. So negative 2, 1. And I can go ahead and make my triangle here, and I can draw this a little bit bigger so it's easier to look at here. And we're looking at this angle here, the reference angle. And this distance right here was 2. And when we went up 1. So 1 squared plus 2 squared is my c squared value. And that would be 1 plus 4 is 5. So c is equal to the square root of 5. And now we can go ahead and evaluate all these trig functions. But before I start evaluating them, I want to put my negatives on there. This is quadrant 2, and all students take calculus. Sine is positive here, and its reciprocal function is positive here. Every other trig function is negative. So I'm going to put those negatives on there so I don't forget. And then looking at our angle here, I can evaluate all 6 trig functions. So sine is opposite over hypotenuse, 1 over the square root of 5. Again, rationalizing, we get root 5 over 5. And then if sine is 1 over square root of 5, cosecant is the reciprocal of that, so that would just be square root 5. Cosine is adjacent over hypotenuse, so 2 over the square root of 5. And I can again rationalize, and that becomes 2 root 5 over 5. And secant is the reciprocal of that, so square root of 5 over 2. And then tangent is going to be opposite over adjacent, so 1/2. And then cotangent is adjacent over hypotenuse, or the reciprocal here, and that would be negative 2. And that brings us to the end of section 3.